Okay. So again, I thank you for meeting with me, Dr. Smith. Um, Now, the first question I have is, what is your current job title?
So I am the SUNY Distinguished Professor of Philosophy here in the University at Buffalo. I also have affiliation with the Department of Computer Science and Engineering and also with the Department of Biomedical Informatics. And I'm also the director of something called the National Center for Ontological Research. I think that's about all the titles at the moment.
Got it. A bit of a collector of titles then. Um, and the work you do at National Center for Ontological Research is something I hope we can talk about because that's very fascinating to me, as I said in the email. Um, Now, how many years in total have you been working in your current position?
Slightly over 30 years.
Okay.
So before that, I worked in Europe, and before that, I worked in the United Kingdom, which is where I grew up.
Yes, sir. And um, in what capacity do you work with research data? And how many years in total have you been working with research data?
Well, that is a complicated question. So I don't actually work very much with data. I work with tools which other people use to work with data. And those tools are called ontologies. And the idea is that if we have ontologies, we have something like controlled vocabularies for describing data. And so if you can persuade people in different domains or in different institutions to use the same ontologies, then one can share data more easily and more successfully. And so I am somebody who has devoted my working life for more than 30 years now to the problem of how to build good ontologies which will be such that you can persuade people to use them. That's the key. I sometimes compare it with a telephone system. So you may have a really crappy telephone system, but you have 100 subscribers, and so it's quite successful. If you have the world's most wonderful telephone system with golden wiring connecting all the phones, but you only have two subscribers, then you have nothing. So
Sure.
I am seeking to have ontologies which are good enough to have many subscribers, which is
Sure.
what I've succeeded in doing in multiple areas along with various collaborators over the years.
Yeah, and actually let's get to that. I know you've worked on different ontology in a number of different domains, from the biomedical to like the economic or social and defense intelligence work. And that's an incredibly diverse and colorful horizon of projects. And you've kind of already touched on it, but throughout all those different projects, what is the common thread? In other words, what kind of work does an ontologist do?
Okay, so that they are two questions really. The common thread is something called basic formal ontology, which is what is called a top level ontology, which means that it's very general. And because it's very general, it can be reused in dozens of different domains, as we call them. So it can be used in biology, it can be used in physics, it can be used in intelligence analysis, it can be used in industry, and it is being used in all of those domains. And I also work on domain ontologies, which are, as it were, on the next level down from basic formal ontology. And I work with other people who are working with domain ontologies, also working in ways which are consistent with BFO. Now, what does a typical, I don't have a typical day. Currently, I'm devoting practically all of my time to a new degree program, which we just established here in Buffalo, which is a master's program in applied ontology, and which will very soon be joined with a PhD program in applied ontology. And this is the first degree program in the world in the field of ontology. So we are quite hopeful that we're going to have something which will be useful and successful. So we had the first intake of students. We have 29 students, I believe, which is also quite remarkable given uh, the relative specialization of knowledge that it takes in order to even know what an ontology is, much less know that there is a degree program in ontology, much less knowing that that degree program is in Buffalo. But since this is online, we actually have students from all over the world, so we are quite pleased with our progress so far.
Of course, that sounds wonderful. And I'm actually excited. I didn't know, I was aware of the master's program in applied ontology, and it definitely has piqued my curiosity. I didn't know you guys are developing a PhD program as well, and that's
Yeah.
very exciting for me. Um, is there a time frame or something like that that you're
So we're
able to share?
waiting for approval from the New York State Department of Education. We have approval already for the master's program. We are told that we will have approval very soon for the PhD program, but we don't have it yet. And I assume that we will have our first intake for the PhD program in the fall. We already have a PhD program in philosophy, which has a track in ontology, but that's not online. In order to participate in that program, which has been there for many years but has had very few students for various reasons, in order to participate in that, you need to be here in Buffalo. Uh, Another feature of the online program is that it's much cheaper than the resident program. So that's, I think, one reason why we had quite a successful intake in the first year.
Sure. And correct me if my understanding is wrong here, but um, it's not just applied ontology in the formal information sciences sense. It's also it interacts, it's interwoven with philosophy. Is that right? It's
Yes, so the world of formal ontology goes back to around 1980, I guess. And for the first 20 years, it was a branch of computer science. The word ontology was used for accidental reasons having to do with Quine's theory of um, ontological commitment. So Patrick Hayes, who was an Englishman working in Stanford, developed what are almost certainly the first formal ontologies. He was trying to develop a formal ontology which would capture the ontological commitments of common sense. Now, Quine was interested in the ontological commitments of science. Patrick Hayes was interested in what it takes for a human being to buy a salad from a salad bar. What
sure.
kind of information do you need to have? What kind of understanding do you need to have about things like money and people and tomatoes and so forth? And so he built this ontology called naive physics. And it was somewhat successful, but it didn't really catch on. It didn't have a large following. I think it was fantastic, but there were all kinds of problems with it. Above all, in order to be functional, it would have to have thousands and thousands of terms. And that means that it would be very difficult to develop because these things, if they're going to work, need to be developed by hand to a large degree. Now, why did Patrick Hayes want to buy salad? Well, he wanted to build a robot. And he thought that if you had an ontology of common sense knowledge and you could get this ontology programmed into a robot, then the robot would have human common sense. Lots of people still think that. That's part of modern AI, the dream of artificial general intelligence. Patrick Hayes was doing it in 1970. And the next important success, I guess, of ontology technology in the computational sense was the Siri app in the iPhone, which is an ontology driven app. And what happened then was around about 90, well, exactly in the year 1998, the gene ontology was founded, which was a hand built, very clever, controlled vocabulary for biology, basically. And it was very successful because it was developed in tandem with the Human Genome Project when people had different bodies of data all over the world which needed to be combined. And the gene ontology made that combination for the first time possible. I became involved there by accident, really, with the gene ontology in 2002 or thereabouts. And I've been working in biomedical and biological ontology projects ever since. So I'm still doing it now. But I branched out into other areas. And I think that answers your question. I've forgotten what your question was.
Yes, you did. I was asking about the kind of work an ontologist does. And
Well,
you did
let
mention
me
it.
just say a couple of things which will tie the philosophy into the picture, and also uh, tell you something about the structure for our graduate program. So we'd see the program as having three pillars. One pillar is technical ontology development and implementation, which is partly logic and partly software. And there is now quite sophisticated ontology software, which is quite easy to use. So people can develop ontologies just as they can use word processors. That doesn't mean they'll develop good or useful ontologies, but the software is there. And then the second pillar is philosophy, by which we mean, roughly speaking, Aristotle and a few more recent philosophers and their ideas, which were the main input into the basic formal ontology. And then the third pillar, which is what we're doing now, is spreading the word. You remember that ontologies are valuable only if they have many subscribers. There are always people who would object to a given ontology because it will not contain their favorite word, or it will define their favorite word in a way which is incompatible with the way they think it should be defined. That means that ontology has always been a kind of pugilistic area. People fight. And I like winning, which
Sure.
means that, and I like other people to like winning also on the same basis. So the third pillar of this program is teaching people how to argue in defense of philosophical principles, ideas, axioms, application methodologies, and so forth.
Mm,
And so there are various different ways of describing the third pillar, but fighting is a good first approximation.
sure. And what's so fascinating about this is that it's an intersection of multiple worlds, as you said, philosophy, working with AI and other and you're also creating sort of the frameworks for future development. So it's not just um, abstractions, let's say, it's technical, practical work. And I know you recently, or well, a few years ago in 2022, you co-wrote a book with Jobst Landgraber. I
Very
don't know if
good.
I'm Oh, good, great. Why Machines Will Never Rule the World, Intelligence Without Fear. And I was wondering what you think about uh, the work or the compatibility and the potential power of the work uh, of an ontologist and AI working together in those two capacities.
So my principal colleague in the faculty for this applied ontology program is a logician by the name of John Beverly. He's not just a logician, he's also an ontologist, and he has a background in medical ethics and other subjects. He is very keen on the idea that ontology can help build better, more reliable AI. And I hope he's right. But the arguments of the book that you just mentioned suggest that for various reasons he might not be right.
Mm,
And the reasons have to do with the fact that um, human intelligence and human consciousness and human thought are all something which happens in complex systems of various sorts. So the brain is a complex system, the environment is a complex system. This conversation involves many complex systems because it's a meeting of minds It's a meeting of what you've learned in your life and what I've learned in my life and the institutions we belong to and so forth. They are all complex systems. And yet we manage to communicate because we're human beings. Now, computers don't have any of the background that you have, and they don't have any of the background that I have. And so, in principle, it should be quite difficult for a computer to communicate with us. Now, if we call our bank and we ask a correct question, even a very straightforward question, we will very often be annoyed because the bank doesn't have the ability to engage in conversation in a way which is comfortable for human beings. Now, Jobst and I started work on our book. He's an AI entrepreneur as well as a philosopher and a mathematician and an MD and various other hats. So he became convinced, building his company in Germany, that it's impossible to build a chatbot which would work in ways which would not require humans to make special attempts in order to have friendly conversations with it. The chatbots in the humanly friendly, useful, natural, smooth flowing sense are impossible. That's his axiom. And he's tried very hard. So he's not coming from nowhere. And that was the basis of the book. Now, we've actually published a second edition of the book. We didn't say enough about physics in the first edition. And of course, the first edition was published in more or less the same week that ChatGPT was released. And so we needed to say more about the GPT tradition to which ChatGPT belonged, because we were there at the very beginning of GPT. And we're now writing a third book, which is a kind of introduction to the rather technical features of the first book and the second edition of the first book. And we haven't changed at all. So we've seen the ChatGPT and all the other large language models come to flourish all around us. They do fantastic things, but they still don't engage in conversations successfully with human beings. And they still, of course, make all kinds of mistakes. They hallucinate, and they will always hallucinate. And we can prove, or it has been proven, that they will always hallucinate. Now, there are two avenues that one can take. One avenue is to say, oh, we just need more scaling, more data, more training material, and we'll eventually reach a point where ChatGPT version 8 will have artificial general intelligence and will have the ability to converse with human beings and indeed will be more intelligent than human beings. We think that that's a non-starter. The second option is that we find a different way to build artificial intelligence. And that's what Patrick Hayes wanted to do already in 1970. And there are some very important people. Gary Marcus is the most important of them, who hold something similar to what Patrick Hayes held, namely, to build AI, you need logic. And that's what John Beverly believes. I mean, you can use a lot of what's been learned through the large language model history when it comes to building better AI, but you need logic. You can't rely on just on probability, which is what ChatGPT relies on. And then there's the third position. So first position is Sam Altman. Second position is Gary Marcus and Patrick Hayes. The third position is a view according to which there will never be artificial intelligence. The machines we have now are not intelligent. They are mathematical equations, and an equation cannot be intelligent, cannot be conscious, cannot be thinking, reasoning, doing any of the things which they say the computer is doing. That's the view I hold. That's the view Jobst holds. That's the view defended in our book. We believe that already what we have can do fantastic things, but sometimes it's dangerous. And so we should be very careful that where we put it and what we let it do. And whether we can produce something which is significantly better than what we have now by using logic, probably we can, but not intelligence. We have to be accustomed to the fact that a mathematical equation can't be intelligent. says we.
Sure. And speaking of logic, one area I maybe would like to work in is AI worldviews, um, and basically developing uh, AIs that think a certain way, right?
Yeah.
And I would assume that ontology is, and logic, of course, they're both very applicable to that. And I was wondering, I don't know to what degree um, a AI researcher can guide an AI through just a pure probabilistic method into a certain mind frame, so to speak. Um, and I was wondering, is that one of the possible advantages of leaning more heavily on ontology in the development of AI?
Yeah, you're describing what John Beverly is trying to do.
Oh, okay.
Somebody who's already been doing it for some time. It sounds as if he's doing something very similar to what you have in mind. It's a man called Bill Hogan, who is a biomedical informatics ontologist in Wisconsin. And he was one of the very first people to have NVIDIA chips running his ontology-based team, running the work of the ontology-based team that he has now in Wisconsin, in the following way. You have ChatGPT, or you have some large language model, which knows a lot about people. So it doesn't know anything, of course. It has mathematical equations which seem to be reasoning about things like humans and diseases and accidents and drugs and so forth. And that's all captured in electronic health records in ordinary English. And so the large language model can capture that language. It's a mess, but it can be captured by the large language model. But then you don't want a mess when you're doing reasoning about drugs or about transfusions or about the effects of drugs or about diagnoses and so on. You want to have ontology. You want to have something logic based and not probability based. And so Hogan's idea is precisely what you say. You have computers to do the natural language, the machine, sorry, well, machine learning based natural language processing. But then on top of that, you have the formal reasoning about data of various sorts, and ultimately about people and diseases and diagnoses and doctors and so forth. So you're on the right track. I'm not saying that you're doing anything wrong. I'm just not quite so confident that you will end up cracking the problem of using AI in such a way that you're not affected by hallucinations. That's what
Yeah,
you're trying to do. You're trying to use logic to block the hallucination. I think that's what John Beverly is trying to do.
sure, sure. I imagine the hallucination problem will be with us for a while, no matter what path we
It will
take.
always be with us.
Yeah.
There is a proof. It's a
Oh, there's proof.
mathematical proof that there will always, every LLM, if it's based on stochastics, will always hallucinate. And the proof is mathematical in nature, but it's a proof. Um, I can
Yeah,
send you the reference if you wish.
yeah. And I have so much more I want to talk about, but I do want to be respectful of your time. We're at 25 minutes now. Um, I said it would be 20 minutes. Are you okay with, I mean, how much time do you really have here? How
We can
feasible?
go for 5 more minutes. That won't be a problem.
Okay, great. So let me go ahead and ask some of the questions here that I'm required to ask. Um, Please indicate your credentials and degrees.
Oh, well, I have a master's degree from Oxford University in mathematics and philosophy. And then I have a PhD from the University of Manchester in philosophy. And I guess that's my only credentials.
Okay,
I also have a bachelor's degree, but that was eaten up by the master's degree.
okay. And please provide any other education or training you have received that is applicable to performing your job.
Not really, no. Just I was teaching at a very early age, so everything I learned from my students.
I see. That's wonderful. Um, and Well, what advice would you give to someone, namely myself, trying to enter the ontology job market?
So we have. I'm going to have to be very careful how I express this. We do not find any problem in getting jobs for our students. So we are very well connected, put it that way. And there is a huge demand for people who are trained in ontology just at the moment.
That's encouraging. Sure. And again, so many questions, but well, you mentioned that Jobst, I think it was, that also works as an entrepreneur in AI. Is that
Yeah.
correct? That was okay. Um, and I mean, there already is uh, media being generated by AI. It can be absolute junk and just pure weird hallucination and stuff like that. But again, I would imagine applying ontology to generate virtual environments like or creating an app that would allow users to generate that kind of thing, whether it's a video game, a movie, a little show, or whatever. That I would imagine that would be very promising. And I wonder what you think about that potential use of this, um, of ontology and AI.
No, I don't. I think that there is interesting work to be done on things like the relationship between the physics of video game worlds on the one hand and real physics on the other hand. I don't know whether you are familiar with David Chalmers' book called Reality Plus.
I've heard
It's
of it.
all about that question. Now, I think he has a very dubious position. He thinks that simulated worlds could be better than the real world. And so, if you can just get some way, some stepping stone into a simulated world, you should take it immediately.
Mhm.
And my answer to that is that he has to go first. Um,
Right.
so I think there are lots of interesting questions to be raised in this sort of field, but I don't think it's going to lead to anything of great value in the way in which paintings by Botticelli are of great value. So,
Mm. Mm.
but who knows? Jobs and I are both very, very impressed with the powers of AI. It is a
Sure.
it just, the problem is the powers come with the also the frightening and sometimes hysterically funny failures.
Of course. Yeah. Well, all right. So we've got 2 minutes. So um so you mentioned logic, of course. What are some of the most valuable tools a student of ontology would want to acquire in order to succeed?
Well, logic is indispensable. You need to have a good grounding in first order logic semantics. Then you need to study a little bit something called OWL, which stands for the Web Ontology Language, which is a fragment of first order logic, which is the de facto standard language for most ontology work. And so that's on the formal side. Then on the domain side, you need to familiarize yourself with one body of ontology work. It could be in medicine, it could be in industry, it could be in finance, could be in law. And then you identify areas which are not covered satisfactorily by that body of work, and then you gain the expertise you need by trying to fill the gaps, or at least that's one good way of getting to know what you need to know.
Sure. Okay. Well, thank you so much for your time, Dr. Smith.
You're very
And
welcome.
I really enjoyed this conversation, and I hope you have a great rest of the day.
Same to you. Good
Take care.
night.